this video, I'm going to go over question 7 from the November 2016 paper 2 for IB Math SL. It's a calculator question, and it is a probability distribution question. So we have a jar containing 5 red, 10 blue, and M green discs. A disc is selected at random, and that process is repeated 4 times. Write down the probability that the first disc you select is red. So that's an easy one. It's a 1-point question. Nearly everybody gets that. So we don't know how many are red. We do know. We know how many are red. Red is 5. We don't know how many are green, but we know that the total would be 5 plus 10 plus M, so 15 plus M, and that's it for part A, and almost everybody gets that. Then, if you're repeating the process 4 times, you should notice that this is a binomial distribution, binomial PDF or CDF question. Let X be the number of red discs selected. So if you're doing this 4 times, you could either get 0 red discs, 1, 2, 3, or 4. And we're finding the smallest value of M for which the variance of X would be less than 0.6. So if you recognize it's binomial, you'll see that there's a formula for variance in the formula booklet for binomial distributions that says the variance of X is equal to N times P times 1 minus P, where N is the number of trials that you're doing. P is the probability of success on 1 trial, and then 1 minus P would be the rest of the probability. So in this scenario, we're doing 4 trials, so N is going to be 4. The probability of success, if success here is defined as selecting a red disc, is the thing we just found from part A, so 5 over 15 plus M. And then the probability of failure, or the rest of the probability, would be 1 minus that result, and this would have to be greater than, is that what it says? Nope, less than 0.6. I'm just reading that from the question. So we're supposed to be solving this inequality for M to try to find the smallest value of M for which this variance comes out to less than 0.6. We don't even need to understand what that means, but we do need to work out the algebra here, which can be a little bit hairy. So this is not that easy to solve with a calculator until we get it a little bit simplified. So I will undertake some of the steps to turn this thing into a more manageable equation until I get it down to something I feel like the calculator can help me solve. So I'm going to start by trying to combine that 1 minus the fraction in these parentheses by changing this to 15 plus M over 15 plus M. That's what I'm changing the 1 to, so that I can have a little common denominator here. And now I can combine these as a single fraction, 15 plus M on the denominator, and the top is going to be 15 minus 5, which is 10 plus M. So now I have this parentheses a little bit cleaned up, and I still had this parentheses, and there's a 4. This has to be less than 0.6. I can keep going with this to try to clean it up a little bit. The denominator is going to be FOIL, which is a little bit of a chore. We have to multiply 15 plus M times 15 plus M. But the numerator is not so bad. It's just 4 times 5, which is 20, and 20 multiplied by 10 plus M, which is going to be 200 plus 20M on the top. On the bottom, if I'm trying to do 15 plus M times 15 plus M, I would want to FOIL it out. Or I can leave it written like this for now. So I can see that now I have a nice little fraction, less than 0.6. I could move that denominator over to the right side by multiplication and FOIL while I'm at it. So 200 plus 20M on the left equals, and over here I have a 0.6, and I'm going to FOIL while I'm at it. So 225 is 15 times 15. Plus 15M plus 15M is plus 30M, and then M times M is M squared. All right, so now I see I'm getting to something that looks like a quadratic, now that I have it all in one line. And we always want to be in the habit of getting rid of denominators when we have them. Sometimes that is a key step in order to go on any further. If I can get this whole quadratic, change it to an equal sign, that's no good. If I can get this whole quadratic to be on one side and have it say less than 0, then the calculator can help me. So if I finish out this process, I would distribute the 0.6, get everything on one side. I'm going to end up with an inequality that looks like 0.6, it doesn't really matter which side we get it on. I'm going to get everything on the right. So we'll have a 0.6 M squared, and we'll have a positive 18M. Nope, that's not true. That would be an intermediate step. I'm just going to skip to the step where it's fully simplified. A minus 2M, and then a minus 65. So now I have a quadratic. I'm going to use the calculator's polynomial tools to help me solve for the M values here. And if it was an equal sign, and it equaled 0, then M would be negative 8.87 and 12.2. But for an inequality like this, where we had to factor or use polynomial tools to solve, the answer is going to be either in between the two results we just found or outside of the two results we just found. So it's either going to be in here or it's going to be out here in one of these regions. And the best way to finish this out is to check something from the middle region, because 0 falls in between these two, and plug that 0 value into the inequality here. So if I plug 0 in, I get 0 minus 65, which is negative 65. And that means 0 is on the left, negative 65 is on the right. So like the 0 from here and the negative 65 from here. And is this a true statement? And it is not. Negative 65 is not more than 0. So that means this is not good. It must be these two regions. And since it was asking for the smallest value of m, for which the variance would be less than 0.6, I know that it can't be down here in this negative side of the world. M cannot be a negative number of disks. So it must be the first whole number past this 12.2. So m must equal 13, the smallest number of disks that would make the variance, less than 0.6. So like most question 7s, it is pretty complicated, but we do have all of the skills if you look at it. That's it.